Assalamu alaikum. Today inshallah we will start with the new topic, electrochemistry or electrolysis. What is electrolysis? If we will make a line here, electro derived from electricity and lysis is the breakdown. So electrolysis is the breakdown by the use of current or electricity. Breakdown of what? It is the breakdown of compounds into its own elements by the use of current. What is the importance to get elements from a compound back? Importance of this is the preparation of certain products in the lab or in a large scale, like the preparation of the important metal, which is aluminium. Aluminium is usually found in compounds, even in the earth crust. To get the pure element of aluminium, the most suitable way or the applicable method is electrolysis. We will see or discuss this later too. Okay. Now we will see what is the compounds to be introduced in electrolytic cell. The compound is called electrolyte. All electrolytes can be used in electrolytic cell? No. We have some conditions to be there for the electrolyte. First, can we know what is an electrolyte? Electrolyte is any compound that can conduct electricity. Conduct electricity, it means it must have either immovable ions or movable electrons. Movable ions like ionic compounds and movable electrons like metals. Here in electrolytic cells, the electrolyte, as we said, must have some conditions. The first one is the electrolyte must be ionic compound. So metals will not be used. Why the use of metals? Metals are already in their elemental form, so no need to be introduced into electrolytic cell. Only ionic compounds will be there. Covalent compounds? Covalent compounds are not electrolytes. Covalent compounds are non-electrolytes, so they will never conduct electricity in the circuit of electrolytic cell. The second condition, these ions of the ionic compound must be movable ions or free to move. How can I know if ions are free to move or not? We have two states for movable ions, either to be molten or to be aqueous solution. Can I ask about sodium chloride as a solid? Is it an electrolyte? Yes, it is an electrolyte. Electrolyte when? In which state? In a solid state? No, in a solid state it is not electrolyte. In a solid state it cannot conduct electricity. Why? Because here in a solid state the ions of sodium and chloride are arranged alternately in the crystal lattice and fixed in position. So simply we will say why sodium chloride as a solid cannot be used an electrolyte in electrolytic cell, because ions are non-movable. They are fixed in position in their crystal lattice. Okay? Another question about sugar solution. Can we use sugar solution to separate elements of carbon, hydrogen or oxygen? No. Why? Sugar solution is a covalent compound. Covalent compounds cannot conduct electricity. They are non-electrolytes. Non-electrolytes will never be used in electrolytic cell. They will never conduct electricity. Okay? Let's see a simple electrolytic cell. It is composed of a battery, wires. At the end of these wires, we are having two electrodes dipped inside a solution of electrolyte or molten electrolyte. The negative part of the battery is called cathode. The electrode that's connected to this part is called the cathode electrode. The positive part of the battery is called anode, and the electrode connected to it is called the anodic electrode. Okay? Let's see what will happen in an electrolytic cell once an electrolyte is introduced inside it. First, we will know about a molten lead bromide as an electrolyte. If we will introduce here in the electrolytic cell lead bromide in its molten form, how can I make a molten form? simply we will add to this electrolytic cell another part, which is flame or a source of heat. This source of heat will ensure that your lead bromide crystals will be always in a molten form during the electrolysis, to keep the condition of movable ions. Good? Okay, then what will happen now? By the passage of current, electrons are pushed from the negative part of the battery or the cathode in the wires till it will reach the electrode here. For the circuit to be completely closed, the current must move inside the solution too. That's why we called our electrons must be dipped inside the solution, not just at the air. If it is at the air, now your circuit will be open. No passage of current in air. Air cannot conduct electricity. The electrodes must be dipped inside the electrolyte molten material, which is molten lead bromide. Current will pass here from the negative cathode, which is having a negative charge at the surface of it, towards the positive anode having a positive charge on the surface of the anode electrode. How this current will pass from the negative electrode to the positive electrode? Here inside the solution we are having movable ions. So one of the common questions in past papers, electrons are responsible for the movement of current in wires, and movable ions are responsible for the conduction of current inside the solution or molten electrolyte. We must pay attention to this part. Okay, so once we will pass a current here, what will happen to our molten lead bromide? Cleavage or breakdown here, separating the metal part and the non-metal part. The metal part will be separated to form a positive ion. The non-metal part will be separated to form a negative ion. So lead here will form a positive lead ion, and the bromine atoms will form the negative bromide ions. Notice that these ions are negative, and we are having positive charges surrounding the electrode here. So they will be attracted to the oppositely charged electrodes, which means bromide ions will be attracted towards, the anode. Positive ions of the metal, here positive lead ions, will be attracted towards the negative electrode, which is the cathode. Good. Why they will be attracted here? To discharge themselves. What the meaning of discharge? To remove their ions and become in neutral atoms once again. So we are having here two half equations happening at both the cathode and anode. At the cathode we are having the positive ions of lead needing to remove the positive charge. To remove a positive charge, I must gain a negative one, so I must gain electrons. Two positive charges means I must gain two electrons, and then it will be an atom of a neutral lead. This atom will be formed inside the electrolytic cell in the form of silver droplets at the bottom of the container or beaker. Why? It's a solid. It should be deposited on the surface of the electrode, which is the cathode here. Note that we are having a source of heat, a flame. So even the lead that will be formed, it will be in a liquid form, droplets. And of course it will settle down at the bottom of the beaker. At the second part, here we have to tell that gaining electrons by the lead ions is considered, gain electrons is reduction. This half equation will be completed by another half equation at the anode, at which the bromide ions, which are negatively charged, need to discharge themselves, remove the negative charge. How can I remove a negative charge here? I must lose electrons. So one bromide ion will lose one electron to form one bromide atom. But to form a molecule here, a molecule of any halogen is composed of two atoms. It is a diatomic molecule. So to form a diatomic molecule of the halogen, we must have two atoms or two ions of bromide. Two ions of bromide will discharge themselves by the loss of two electrons and form two atoms of bromide that will combine together to form one molecule of bromine, which is Igcse. This bromine gas is known as reddish brown fumes at the anode. Note that we have to remember or write down all the physical properties of the products formed either at the anode or the cathode. Once again, we can tell here that as bromide ions is losing electrons, so we can consider this half equation as loss of electrons is considered oxidation. Oxidation and reduction here, these are two parts of a complete equation. We can tell that lead bromide by electrolysis will form lead as a neutral atom or a metal, and bromine as a gas.